Okay, so this lesson is on separation of variables. If you're given an equation in which the derivative of a function is equal to some function, you can find the original function by integrating both sides of the equation and then solving it for the constant term. Guys, what is this? That's a derivative. So this is a equation of a derivative. It is an equation that we are going to integrate, correct? Are we going to integrate it? What does integrating mean? Take the antiderivative. So this equation has already been derivatized, taken the derivative of. That's why these are called differentiable equations, and that's why it's called Diff-EQ, because these are differentiable equations. So, because it's already a derivative, we're going to take the antiderivative. Before we do that, you need to get all your y's and your dy's together, and all your x's and your dx's together. So, with this, how are we going to do that? Okay, multiply both sides by y, and then multiply by dx. So those are going to cancel, and those are going to cancel. So I have y dy equals 4x dx. So far, so good? Okay, what's next? I have separated them. The goal is to get back to the original problem, so I'm going to integrate them. Now, on this side, I'm taking the integral of y with respect to y. So just follow your regular rules. What do you get? Exactly, plus c. Remember how we were in such the good habit of putting the plus c? When did we stop doing that? When we had a definite integral, when we had a from here to here. So now that we don't have that, don't forget your plus c. Okay, equals 2x squared plus c. Well, you have a plus c and a plus c. What do those represent? Constants. Do they necessarily have to be the same constant? So if I subtract one over, are they going to cancel? No. These are just two constants. Guys, if they're two constants, can I just sort of subtract him over here and combine them together and make it so that there's just one c? It's just a constant. It's just some number. It just represents some number that doesn't have a variable. Okay, now it says find an equation for y in terms of x. So what does that want me to do? Yep. So what's left to do here? Not divide by 2. Multiply by 2. And don't put 2c. It's just a c. It's just a constant. And then root both sides. What are you going to have? What are we missing out here? Plus or minus. Good. Okay. Did it give me another piece of information? What? Plug in 0 for x, and you should get a 5 out. What's that going to help me find? That's giving me an x and a y. That's going to help me find the constant. So if I plug in my, was it 5? 5 for my y, my 0 for my x, this all goes to 0. So I have plus or minus the square root of c. So now what do I do? Yep, so c equals 25. So now, everybody okay? All right, now, if plugging your 0 and your 5 into this makes you nervous, you can plug your 0 and your 5 into that step or that step. You'll still get a 25. 5 squared is 25 times 0 squared plus c. Do you see how you still get a 25? So he can go into any step that's easier. So if these get hairy, a little ugly, you can plug them back into before you actually solve for y if you want to. But this is your final answer. Okay, are we good? What is step number 1? And what's the name of these notes? Separation of variables. And that's what you're doing. You're separating your variables so you can solve the differentiable equation, the Diff-EQ. Okay, number dos. Okay, ready? I'm going to multiply by 2y and multiply by dx. So I'm going to get 2y dy equals 3x dx. Everybody's separated. Everybody's good. Now what? Integrate. So y squared equals and the c's get to kind of morph together. Okay, do you want to go ahead and plug stuff in here to get your C, or do y'all want to solve it out? It's your call. Solve it out. Okay, so I'm going to root both sides. Okay, so now I'm going to plug who in for what? 0 in for x, 10 in for y. 0 in for x, 10 in for y. So what's C going to equal? So then y equals plus or minus . Okay, still good? Told you this was nice and medium. Okay, a little different. I still need to separate my variables. I need to get my x's and my dx's together and my y's and my dy's together. So what do you want to do? Okay, divide my y squared, but then multiply by dx. Y to the negative 2 dy equals 4x dx. Okay, integrate. So negative 1 over y. Combine your c's. And I'm supposed to solve for who? Y. How do I do that? I can run a negative through, right? Like I can fix that part. Can't we? I'm still going to put a plus c. Plus c minus c, it doesn't matter. It's just a constant. It doesn't matter what its sign is. Yeah, if 1 over y equals that, then y equals 1 over that. I mean, you can put it over 1 and cross multiply if you want to, but okay. Now what? Plug a 0 in for x and a 1 in for y. So if I flip this and flip the other side, c is going to equal 1. Or you can multiply both sides by c and then divide by 1. Either way, you get c equals 1. So then y equals plus 1. Everybody okay? All right, cool. Number 4, two things are different. What's one thing? That's y prime instead of dy dx. Same thing. I don't have a point. So am I going to be able to find c? So that's just less work we have to do. They didn't give us enough information. I can't find it. So I'm just going to have a plus c. All right, so I'm going to change the y prime to dy dx. Go ahead and start separating your variables. So yay, less work. Everybody okay? All right. Gonna crank it up 1 notch. Got my dy dx, got my point so I can find my c. I need to first separate my variables. Okay, so how do I do that? Divide by y. So dy over y equals 3x squared dx. And you could write it y to the negative 1 if you wanted to. We had one that was y to the negative 2, and we did that. Okay. What's different about this one? Can I use my regular rule? But why? How do you know? Yeah. If you add 1 to your negative 1, it's going to make it a 0, and that's bad. So this is one of those ones that you have to remember. And that's why I wrote it as dy over y instead of y to the negative 1. U-substitution. Okay, so if your u was your y, what's your u prime? 1. Do I have everything I need? So if, for this, if my u is y, my u prime is 1 dy, then don't I have u prime over u? And what was that one? ln of u. So this is ln of y, right? Because my u is y, plus c. And then 3, so 1x cubed plus c. Okay, now I'm going to test some algebra skills. Let's see. Ln of y equals x cubed plus c. I want to solve that for y. Equals, how'd you get it? You snail it. That, yeah, the loopty thing. Yeah, his base is e, and it's this to the this equals that. Y'all remember that? Math 3 and pre-cal. Nice little log snailing. E to the x to the third plus c equals y. Does that ring a bell? Oh, you've seen that? Good. Everybody? Yeah, it's back there? All right. Okay. I have e to the x to the third plus c. Bless you. Think about exponent rules. It's a plus in my power. What makes you add your powers? In what instance would you add your powers? Multiplying. Like if we were back in math 1 and I gave you x squared times x to the 5th, you would get what? X to the 7th. You're doing 2 plus 5, right? Now use that rule backwards. This has been added. This is your 7 right here. So that could be broken down to e to the times e to the, there you go. Guys, what's e? A constant. It's a constant to a, so what is that? It's just one big fat constant. E is 2 point and some change. E to a constant is a constant. So guys, here's what you have. Just put your constant out front because that's where we're used to seeing it with e's when it's being multiplied. Now that trick right there, you're going to do a couple times today. So it's not a one and done kind of thing. Okay, now I have solved for y. Am I done? Did it give me information to find my c? Okay, then let's go find my c. It gave me the point what? What's your x value? Yeah, 0, 2. So 2 is my y. I don't know my c. E to the 2 cubed. See, it's not 2. It's a 0. Good job. Making sure y'all are paying attention. What's 0 cubed? 0. What's anything to the 0? 1. What's 1 times c? C. So c equals 2. Because all of this goes to 1. So now I know that I'm this. Okay, I'm going to point out something on my sweet little Math 1 poster. Y'all see this exponential function right here? This is exponential. Does this kind of look like what we have? Y'all see this a right here? What is he? Your starting amount. If my point is 0, 2, isn't that my starting amount or my y-intercept? So if my point is 0, 2, does it make sense that I'm going to have a 2 right here? But, I mean, that's what you learned in Math 1, hopefully. Now, if this 0 was anything other than a 0, then I don't know that there's going to be a 2 right here, and there's not going to be a 2 right there. But if that point's a 0 and you do this math and you get a 2 right here, you should be like, oh, okay, yeah, that makes sense, because that's my starting value. Your starting value for exponentials always goes right there. Okay, this is what we're going to spend a lot of time on after we finish number 6. Okay. Find an equation for y in terms of x. Okay, separate your variables. Ooh, no, that didn't work. I don't want to multiply by x. Do I? I just multiplied both sides by x. Do I want to do that? No, I don't want to move the x over here with the dy. You want to multiply by dx? Okay, I'm with you there. So here's what I've got. I've got dy equals y squared, and I can write that x to the negative 1 if that makes us feel better, dx. So now who's in the wrong spot? I do. I have to divide by y squared, or over here I can write y to the negative 2. Okay, which one of these is cool and which one of these is funky? The y's okay, right? My powers will hold up. So when I integrate, that's going to be 1 over negative 1 y to the negative 1 plus c. This is x to the negative 1, which is, I can't use my power rule because it's going to give me a 0. So instead of thinking about him like this, think about him like this. And do your u sub, which is what we did on the last problem. So your u is going to be your x. Your u prime is going to be 1. So you have u prime over u, which is ln of x. Do a little bit of cleaning. Do y'all want to write that as y to the negative 1 or 1 over y? I'll go either way. 1 over y. You got it. Combine my c's. Now, do y'all want to keep going? And we're going to have to keep going, but do you want to keep going and then find c, or do you want to find c here? Because we're about to subtract a c in snail stuff. So I'm kind of thinking maybe we should plug stuff in here before things get dicey. Okay, so my point is 1/3. So if I plug a 1/3 in for my y and it's on the bottom, what's going to happen? You're going to Bojangles and get a what? Yeah, a 3, and he's negative. So negative 3 ln of 1 plus c. And what's ln of 1? 0. So C equals -3. Okay, so now I'm here. You know what? I'm not going to snail this. Why am I not about to snail this? Who are you solving for? Haha, I'm solving for y. I don't have to snail anything. What do I need to do? Run the negative through and flip him. So y is going to equal, I'm just going to put a -1 on top. Are y'all okay with that? Instead of making it -ln of x plus 3, which you could, that'd be fine. Okay, everybody all right? Okay, here we go. Here's the why we do these. In many applications, the rate of change of a variable is proportional to the value of y. Okay, that's a powerful sentence. Let's say that again. In many applications, the rate of change of a variable, look, rate of change in relation to time of a variable, y, is proportional to the value of y. Do y'all remember K? Math 2, first thing you did, direct and indirect variation. Y is directly related to x. Y is inversely related to the square of t. Y'all remember doing stuff like that? And you would have to find K. K is called your constant of proportionality. It is how they are related. If you take this, the rate of change is directly proportional to y. Can we take this equation right here and solve it for y? What would you do? K is a constant. You only have two variables, a y and a t. What would you do? I'm solving for y. I want the original problem for y. We just did 6 examples. Do what? Divide by y to get them over with a dy? Perfect. And do what with the dt? Is it the k that's throwing you off? K is just a number. It's not a variable. It's just a number. So it'll be k dt because you multiply both sides by dt. K is a constant of proportionality. It is a number. It is a constant. We just don't know what it is. Okay, now, do what to get rid of the dy and the dt? Integrate. Okay, and you need to have this process. You need to write it down. Off to the side or in the corner or in this little space, but you need to have this process. Okay, we know what this one is, right? What's that one going to be? Ln of y equals k is not a variable. How do you integrate a constant? If I said, what's the integral of 5? It would be 5x. Well, this is the integral of k with relation to t, so kt. And I'm just going to put 1 plus c. Are y'all cool with that? Instead of 1 on each side and then moving it over. Okay, now again, if I want to solve for y, what would I do? Snail it. His little base is an e. We just don't write it. So this is going to be e to the kt plus c equals y. What can you do with the e to the kt plus c? You're going to make that e to the kt and e to the c equals y. And what's e to the c? The same thing as just a c, and I'm just going to pop them out front. And that's where that comes from. And who is C? We very briefly talked about it and went over to the poster. Who is C? Your starting amount. It's your starting amount. T is time. What's K? Constant of proportionality. Yeah. So guys, you have two constants here. You have C and you have K. You have two variables, Y and T. But you have two constants. C is the initial value of y, and k is the proportionality constant. Exponential growth occurs when k is bigger than 0, and decay occurs when k is less than 0. Okay, here we go. The rate of change of y is proportional to y. Stop right there. The rate of change of y. How would you write that? The rate of change of y. dy dt. dy dt. The rate of change of y is, what does is mean? Very good. Equals. Proportional to y. Ky. All right, now, when we separate our variables and do all that stuff, what are we going to get? Y equals what? Ce to the kt. That's just where you insert that whole process that we just did up there in the corner. Okay? All right, so now I have this. Now it says when t equals 0, y is 2. When t equals 0, y is 2. So can we plug some stuff in? Okay, what do you know? Don't know C. E. Don't know K. But what's T? So 0 takes care of the K for me, right? E to the 0 is, and 1 times C is, and C is 2. Should we have also just been able to look at this and say, oh, when t is 0, well, that's time. So that's my starting value. So that would make sense that 2 is my C. Okay, so now I'm going to take this guy right here and I'm going to plug in what we just found. But what do I still not know? I still don't know K. The final question says find the value of y when t is 3. So I know t is 3 and I want y, but I got to find k first. But it gives me another piece of information. It says when t is 2, y is 4. So if I know t and I know y, can I use this to find k? All right, we'll plug some stuff in. 4. Okay, how do you solve this? What are you going to do first? Yeah, divide by 2. And I'm going to make this 2k instead of k2. All right. What's next? Bye. No, you could do that. That would add a couple steps to it, but you could totally do that. We're going to snail it. I snail better when my equals is over there. All right. What log is base E? Okay. So ln of 2 equals 2k. Y'all see? I snailed it. ln of 2 equals 2k. And you're going to have to do that a lot, so let's stare at that for a second. I knew to ln it because it was an e. So ln's base is e. Then think about it. If you snailed this, wouldn't this be e to the 2k equals 2? And then what I have right there? It's a lot of lines. ln of 2 equals 2k. Guys, ln is a button on your calculator, isn't it? And 2 has no variables in it. So can I figure out what ln of 2 is and then do what? Divide it by 2? So k equals ln of 2 over 2, and y'all are going to get me a decimal for that. Let's go 3 decimal places. So now we know k. So now I can take this guy and build an equation where I know all my constants. Now, you give me a t, I can find you a y. You give me a y, I can tell you a t, because now I know how these two variables are related. And it says, what is the value of y when t is 3? Just straight up type it in. Okay, let's backtrack just a second. Are we okay with this part? The rate of change of y is proportional to y. So far, so good? Yes? Is that a yes? Okay. Do you know all the steps that are involved jumping from the box to the circle? If it's a free response, yes. If it's not, no. All right, so then we're here. And does everybody understand that you have two constants here? So it should give you enough information to find both constants. It gave me enough information because t was 0, wiped out him, so I could find c. Plugged my c in. Then it gave me a y and a t, so I could find my k. Now, how are you going from this to this? Just snailing. ln base e of 2 equals 2k. Like a snail or an ear, however you want to. A lima bean. The little girl from West that I'm tutoring, she said her teacher calls it a wagon wheel. Made me want to sing wagon wheel every time we did it. Whatever works. Whatever works. Then once I knew my k, then I could plug it back into my formula with my c and then find what they wanted me to find. Again, is this difficult? No, it's not difficult. Are there 1,000 steps? Yes, absolutely. Okay. We got fruit flies. An experimental population of fruit flies increases according to the law of exponential growth. Underline the words exponential growth because that's how you know what formula you are. There were 100 flies after the second day of the experiment and 300 flies after the fourth day. Approximately how many flies were in the original? So what, guys, what are we looking for? There you go. I'm looking for C. Okay, so what's my equation for exponential growth? Y equals C e to the kt. There were 100 flies after the second day and 300 flies after the fourth day. All right, tell me what we can do. Tell me what we know. What can we plug in? Do y'all agree with that? 100 for your y and 2 for your t? Okay, let's try that. But then if I do it again with the 300 and the fourth day, I have two equations. I have two things. I don't know what they are. How can I solve this? Like, I don't know C in either one of them. I don't know K in either one of them. I have two equations with two things I don't know. My Math 1 babies just took a test on this today. I mean, not with exponential functions. It was linear. But there were two equations. They both had an X and a Y. Can I set these equal to each other? No, but the ballpark is on the road. I don't know if we can see the ballpark yet, but we're at least on the right road. I can't set. I'd have an E. And then what? That's okay. You're thinking. I like it. You do manipulate one of them. Yeah, that would work. Not what I would do, but that would totally work. Mm-hmm. Substitution. Now remember doing systems where the goal was to find the point where the two lines crossed, and you do it with substitution or elimination. Remember when you would multiply an equation by something to get two variables to cancel out? It's been 4 years since you've done that. 5. It's been a while. It was like x plus 2y equals 5 and 3x minus y equals 2, and your job was to find the point where so you'd multiply this guy by 2 so that your y's would cancel. No, nothing? Y'all remember any of this? Dang. All right, well, I'm going to solve this guy for C. Done. I'm going to solve him for C because then what can I do with that 100 over e to the 2k? He equals C. I can put him right here. What's the point of doing that? How many variables do I have now? I only have one. I have K. I mean, I have a couple Ks, but I have only one variable. All right, so 300, 100. Instead of over, can I do, are y'all okay with that? Okay, use your power rules. They both have the same base. When you multiply, what do you do to your power? You add. Okay, what's next? Divide by 100, so 3. Yeah, this is the snail. Again, for some reason, I cannot snail when my equals is over here. It has to be over there. I don't know why. So let's see, this is going to be what? ln of 3 equals 2k. Look at y'all. And then what? Divide by 2. And then it's straight calculator. Go 3 decimal places. 0.549. Okay, is that my answer? Is that how many fruit flies we started with? What is that? That's your K. Okay, now hold on. Time out. Everybody stop. What is that? And don't say your K. And don't say your constant proportionality. What is that? What does that mean in terms of fruit flies? She said that's how fast they're multiplying. You're so close. That number's less than 1. What happens when you multiply numbers by numbers that are less than 1? What happens to the number? It goes down. So what's happening to our fruit flies? It's decreasing. How many fruit flies did we have? Oh, they're increasing. That's not your C, that's your K. Shoot! But that's your constant. But it's e to the, that's right. If it wasn't a power, yes, then that would have worked. Okay, so here we go. I got y equals c e to the 0.549t. Right? What did it want? The original. Do I want to use that formula I just wrote down? Yeah, look at the one that's right above that that says C equals. How about that one? Because I want C. I want how many I started with. And I have the 100. E I'm good with. 2 I'm good with. And didn't I just find K? Sweet. Let's use this guy. Be very careful typing that in. Go 3 decimal places, even though it doesn't make sense for flies. What do you think? Do y'all see how none of these are exactly the same? You got to think. You got to understand what the letters represent. All right. Next. Okay, now we got a population. A city had a population of 10,000 in 1980 and 13,000 in 1990. Assuming an exponential growth rate, estimate the city's population in 2000. I have a different, did I miss one? There it is. Okay. So we are exponential growth, so what's our equation? There you go. Okay. Talk to me about 1980. Can we initialize that? Can we make 1980 our initial population? Absolutely. So if we say, I hereby declare that 1980 is t equals 0, what's 1990? T equals 10, and what's 2000? T equals 20. If I now know that t equals 0 is 10,000, what have you just found? Your C, your starting point. Now, if you don't see that, then watch. You're going to do this, which is totally fine. What's k times 0? What's e to the 0? And what's 1 times c? C, and so C would equal 10,000. And then you're going to go, oh, that's right, I could have just skipped all that, which is totally fine if you don't see it, because you can still get there. So now I'm here. What do I not know? I found one of my constants. I found my C. But now I need my K. So what other information did they give me so I can find my K? And do I plug in a 1990? It's going to give you a set of data that you can plug in to find your K. All right, divide that sucker over. I'm going to leave it as 13 over 10. It's just cleaner. Yeah, I got to move my... So ln of 13 over 10 equals 10k. Divide by 10. Then that's straight up calculator. Go 3 decimal places, but you know I don't like zeros. What do we got? You got it. Okay, awesome. That's K and I know C. So now I'm going to take this guy. .0262p. Yeah, it wants the population in the year 2000. We baselined it at 1980, so 2000 is now 20. Plug a 20 in for your T. And just like with the fruit flies, I'm still going to label it people, and I'm still going to go 3 decimal places, even though that doesn't make sense. On the calculus exam, they are very clear that you absolutely, your numbers have to be correct to 3 decimal places. So a lot of teachers throughout the whole year will say, we're going to go 4 decimal places. That way, if your 4th decimal place is wrong, if you round incorrectly, you're still right to 3 decimal places. But I'm assuming y'all can round. All right. 4 months after it stops advertising, a manufacturing company notices sales have dropped from 100,000 units per month to 80,000 units per month. The sales follow an exponential pattern of decline. What will the sales be after another 2 months? Everybody sees the exponential pattern. That's your clue. That's how you know what your model is. Go ahead and start plugging some stuff in. Now it says, what will be the sales after another 2 months? Do I plug in a 2? Plug in a 6. $71,548.117 what units? All right, how are we doing? Yeah, everybody okay? Cole, you good? Okay. 10 grams of the plutonium isotope, I'm guessing that's some chemistry, were released into a nuclear accident. Does not sound good. How long will it take for the 10 grams to decay to 1 gram? One piece of information you need to know is that the half-life is 24,100 years. What does that mean when you say it's half-life? Right. So you have 10 grams. So what does that mean? Yep, it's going to take over 24,000 years for it to decay down to 5 grams. So is this a quick dissolving substance, evaporating, however it goes away? No, it's going to be there for a while. And I don't want to get to 5 grams. I want to go all the way to 1 gram. Okay, anything that doubles or triples or halves or thirds is all exponential growth or decay. This is exponential decay because it's going down. So we're here. Okay, tell me what you know. I'm starting with 10 grams. What else do you know? So where do I put what? What goes in place of the Y? 5. Because what's T stand for? And when you divide 10 over, guys, what do you get? A half. See, it's a half-life. You get a half. Okay, I gotta move my 1/2. All right, let's nail it. ln of 1/2 divide. I'll save you some buttons. Oh my. -0.0000287761. I don't know why I got a little overzealous with my decimals and went that far with my decimals. 0.0000287761, and it's negative. No, that's a 1, and then equals. It's not an F. I don't understand. Okay, so now I go back here. Negative point. 1, 2, 3, 4. 2, 8, 7, 6, 1, T. Okay, now, what do I want? I got to get down to 1 gram. Where do you put the 1? Is that a T? Is that a time? That's your Y. I'm already overriding this decimal. Okay, what you going to do now? Divide by 10. Does it make sense that you're getting a tenth here? Because you're starting with 10 and you want to get down to 1, so I want to be a tenth of what I started with. So ln of 1/10 equals 761 t. Divide by that number. I cannot write it again. It takes a little bit of time. Type that in, see what you get. $80,059.285 what? Years. This is the year 2000. That's 80,000. That's some potent stuff. Bless you. I know, right? Okay, last thing. Totally different. Well, not totally different. Sort of different. The acceleration of a particle. Ooh, physics just perked right up, right? The acceleration of a particle is given by that thing. Initial velocity of the particle is 64 feet per second, and the height of the particle is 32 feet at time 0. Find the equation of the particle's velocity at time t. Find the equation of the particle's height at time t. And find the max height of the particle. Didn't I give you a formula for position? What was the formula for position? S sub t negative 16, because gravity pulls you back down, t squared plus, what goes next? Initial velocity, t, plus initial height. Didn't I give you all that information? Okay. I want you to now pretend that you don't know that. You don't know that formula. We're going to build that formula off of the information that we were given. Okay? So, tell me what you know. You know that acceleration is negative 32 feet per second squared. How are all these formulas related? You have position, and then velocity is what? In relation to position? Yes, the derivative of position. And then acceleration is the derivative of velocity, or the second derivative of position. Did she sneeze or yell? Okay. All right. Now I have this, and I want this. So aren't we going backwards? If I have velocity and I want acceleration, I just take the derivative of velocity and I got it. I don't have that. I have acceleration. So what can I do to acceleration to help me get velocity? Velocity is going to equal the, there you go, the integral, because we're going the other way. Okay, so v sub t equals the integral of negative 32. Well, that's easy. What does that give you? Oh, maybe, yeah, negative 32 t plus c. Thank you. That pesky little c. Okay, but did it tell me something so that I can find c? The initial velocity of the particle is 64, so what does that tell me? If your velocity equals negative 32 t plus c, initial means time is what? 0. What is your velocity? What did it say? 64. So c equals 64. I know y'all can just see that your c would be 64, but I'm trying to show you where it comes from. If it's initial, it's when your time is 0. Put your 64 in velocity, solve for c. So now I know this guy is that. And that's part, what did we just answer? Part A. Part B says it wants the position. Well, I now know velocity. So how can I get position out of velocity? Take the integral. Position formula is the integral of the velocity formula. Okay, so what do we get? Negative 16t squared plus 64t plus 0. Okay, but it told me something. What did it tell me? The height of the particle is 32 feet at time 0. So its height is 32 at time 0, which means c equals 32. So the position and that's where that comes from. Okay. What's part C asking? Find the max height. Is that velocity and acceleration or position? That's a position. Does everybody agree with that? So I want the position. Well, the position formula is based on t. So I need to find the time at which the max height occurs. Does everybody agree with that? Okay, max height. So this thing, it's a negative parabola, right? So it's going to go up, then it's going to run out of velocity, and gravity is going to pull it back down. Its max height occurs here. where it has a what? A horizontal tangent line. And what's the slope of a horizontal tangent line? And how do you get the equation of the tangent line of that? Take the derivative. So you're going to take the derivative of the position formula. You're going to set it equal to 0 because I want the slope of the tangent line to be 0 because that's how I know I've hit a max height. So I'm going to subtract 64, divide by negative 32, and I get t is 2. Now, what happens when t is 2? What does that mean? That's where? That's when. It's when it hits its max height. So I know that it hits its max height after 2 seconds. But the question said, what is its max height? Who do you plug it back into? The position formula. So I have to go find that. I got 96. You want to take my word for it? 96 feet, because it's just a height. Feet. All right, y'all good? Okay, so your homework on this is a whopping 8 problems, but you see that they take some time. And then what else do you need to do? You need to go watch Slope Field. The video, I think, is like 22 minutes. The homework is short and sweet. Thursday, well, the homework's not crazy short and sweet. I would not do all of this at one time. Like, I would do the differential equations, like this homework, and then Monday, I would do slope fields. But I would not go into Monday night and try to do all of this, okay? Tuesday, we review, and Thursday, test.